Hello everyone, welcome back. In my previous video, we built a traditional Azure hub and spoke network. In that setup, we manually created a hub virtual network, connected spoke networks using peering, and forced traffic through a firewall using route tables. That architecture is very powerful because it teaches how routing works inside Azure. But as environment grows and expand into multiple regions, managing that architecture becomes complex. That is where Azure Virtual WAN comes in. Today, we are going to understand how Azure Virtual WAN simplifies networking, and then we will build a real multi-region architecture step by step. Before we start the demo, let us understand the core concept using this diagram. When you look at this diagram, the most important thing to notice is the center. At the center, you see Azure Virtual WAN. You can think of this as a Microsoft managed networking backbone. So instead of connecting network one by one, everything connects into this central hub system. At the top of the diagram, you see multiple Azure virtual networks. This represents application networks or workload running in Azure. When this VNet connect to virtual one hub, Azure automatically allows them to connect with other connected networks. We do not need to manually configure peering or route tables like we did in hub and spoke. On the left side of the diagram, you see an on-premise data center connected using ExpressRoute. This represents a private connection between a company's data center and Azure. Once connected to Virtual WAN, that data center becomes part of the same routing fabric and can securely communicate with Azure workloads. At the bottom of the diagram, you see branch office connected through site-to-site VPN or SD-WAN devices. Each branch becomes part of the same global network. Instead of creating separate tunnels between every location, Azure centralizes all routing through a virtual WAN hub. On the right side, you see a remote user connecting through point-to-site VPN. This allows employees to securely access cloud resources from laptop or mobile devices. Again, all traffic flows through the same managed hub. The key idea here is simple. No matter where traffic comes from, Azure routes it to through Virtual WAN hub and sends it to the correct destination. Azure manages the routing logic behind the scene. We focus on architecture, not manual networking complexity. Now, let us connect this idea with the hub and spoke model we built earlier. In a hub and spoke architecture, we manually design the transit network. We create peering connections, configure route tables, and force traffic through firewall. This gives us full control, which is a great for learning in small environment. However, when we scale hub and spoke across region, complexity increases quickly. We must manage multiple hubs, duplicate firewall rules, maintain route consistency, and troubleshoot across region routing. Every chain touches many components. Virtual WAN, on the other hand, changes this model. Instead of building and managing all routing ourselves, we attach network to a managed hub. Azure automatically propagates routes, handles connectivity, and support global scale. A simple way to think about it is this. Hub and spoke is like building your own road system. Virtual WAN is like Azure providing a managed highway network that you simply connect to. Both models are important. Hub and spoke teaches networking fundamentals. Virtual WAN shows how Azure abstract complexity for enterprise scale. Now let's dive directly into the demo. For the demo, I have logged into the Azure portal. So first, what we will do is You will create a virtual WAN resource. This acts as a global networking container. Remember, it does not route traffic itself, but it manages the hub that do it. Next, after creating the virtual WAN, we'll create a virtual hub. This virtual hub becomes our transit router. Think of it as the traffic controller between networks. After the hub is ready, we create our first virtual network. Inside this network, we deploy a virtual machine. This represents one application workload. Then we create a second virtual network with another virtual machine. This simulates another workload in a separate network. Now we connect both VNets to the virtual hub. This is where the magic happens. Once connected, Azure automatically propagates routes between the network. So now let's begin. First, what I'll do is I'll go to virtual WANs. Currently, there is none. I'll create one. I'll create a resource group, make it as RG WAN demo. Okay. Region I'll keep it as it is and give the name as WAN demo standard. I'll review and create. We'll wait for the deployment. Normally it takes some times, but if it can take more than 10 minutes as well, we'll wait for it. But it got created very easily this time. So let's go to it. Now so once the WAN is created, what we will do is we'll go here in the connectivity. You can see you can create hub, VPN sites, explorer route circuits, and virtual networks. So let's first create a hub, right, which is going to act as our transit router. Now there is no hubs, I'll create one. Okay, I'll keep it as region as Central India, and name I will give as demo hub. The address space I will take it as the minimum capacity is, I guess, fine for this demo. Routing preference I will take it as express route if it exists. Okay, rest of the settings I'll keep it as default and I'll create. Now if you see a message, it says that it will take around 30 minutes to create. So I will let this resource get created and I will be back once this resource is created. Now my hub is ready. You can go to the resource. Now what we will do is we'll create a virtual network. Okay, so let's first create our first virtual network. We'll select the resource group which we already created and we'll give it as VNet1. Region will keep as it is. IP address will make it as 10.10. We'll delete the default and create a new subnet which will give us VM1 subnet. Okay, and this one will keep it as 1. Okay, we'll add this. Now we want to connect to this VM through our Azure Bastion. Okay, so let's create Bastion subnet as well. This name has to be this. Okay, we'll keep this one as say say 6. Okay, and add. I'll say review and create and create. This virtual network is created. We'll go and create another virtual network. We'll select the same resource group. This we'll call it as VNet2. Again, in the same region, IP addressing we'll give it as 10.20. Okay, we'll delete the default subnet. We'll create a new one, VM2 subnet, and this will give it as 1, and then this should be fine. We'll create. The second VM is also created. Now we'll do is we'll create a virtual machine in each VM. Okay, we'll create virtual machine. We'll select the same resource group. This will be VM1, same region, no infrastructure. Rest all, I'll keep it as it is. I'll give Azure user. Okay, I go to networking. I'll select VNet1. I'll select subnet1. Okay, I will not associate. I will not keep any public IP with for this because I'll be using Bastion to connect to this VM. Okay, let's now everything should be fine. Okay, great. We'll wait for the VM to be deployed. Meanwhile, we can go here and try to create another VM in VNet2. Okay, I'll go to networking. I'll select VNet2 and this subnet. Again, I'm not going to associate any IP with this. Rest all I can keep as it is and I'll create. Create. Now it's creating the virtual machine. So what we have done till now is we have created a a WAN resource. In that WAN, we have created a hub and two virtual networks, each having one virtual machine. Now, what we will do is once this virtual machine is deployed, we'll go ahead and connect our virtual network to the hub. I have created the virtual machine within the two VNets that I created. I'll connect those virtual networks to the hub. So let's go and connect it to the hub. So I'll open the WAN resource that we created. We'll click it here. It will wait for it to load. And once it loads, it will show the hub and how many current VNet connection it has. Okay. So you can see you have the hub and currently it is not having any virtual network connections. We'll go here and connect it. We'll give VNet 1 connection. Hub will take this one. Resource group will take this one. Okay. VNet 1. Rest all will keep it as it is and we'll create. So if you see, when we were creating hub spoke network topology, we created the hub VNet and the spoke VNet, and we created the pairing between the hub and spoke manually. But in case of WAN, we don't have to create this pairing manually. If you see, Azure creates the pairing when we connect the network to the hub, right? So we'll wait for it to finish, and then we'll connect the another net as well. Now I have connected my virtual networks to the hub, which you can see here, right? VNet 1 and VNet 2. Also, if you see here, uh, we created the peering, right? The Azure itself created the peering. We did not configure peering manually, right? So now what we do is we'll test the connectivity. We what we'll do is we'll connect to the first VM, okay, using Bastion. Bastion gives us secure browser access without exposing public IP addresses. From VM1, we will ping VM2. The traffic flows into the virtual hub and is routed to the destination network automatically. This confirms that the hub is acting as a centralized transit router. So let's test it out. So I'll go here, I'll connect by Bastion. I've given Azure user and I'll give the password. I'll say connect. Okay. So if you see, I'm able to connect to the VM1. Okay. Now let's ping VM2. We'll go and take the private IP of VM2. And you see, we are getting the response back from VN2. So what just happened? We need to understand what exactly happened here. So the virtual hub maintains a routing table for connected networks. When VM1 sends traffic to VM2, the hub determines the correct path and forwards the traffic. This is managed routing. We did not manually configure anything. Azure abstracts the complexity, right? Now what we can do is we can also SSH into VM2. Let's do that. And you can see I'm able to connect to VM2 as well, right? So this is what uh, is Azure Hub capabilities, right? It simplifies our management overhead of a network as compared to hub spoke network topology. Not only that, Azure Hub provides many other benefit as well. Something like we can connect firewall as well to Azure virtual hub. Okay, when so what happens is when the hub connects to the firewall, it becomes secured hub by integrating with Azure Firewall. And when firewall routing is enabled, all outbound or inter-network traffic can be inspected centrally. So instead of forcing traffic through firewall using route tables like hub and spoke, Virtual WAN uses routing intent. Azure automatically sends traffic through the firewall based on policy. This gives enterprises centralized security enforcement without complicated routing design. We are skipping firewall deployment here to keep the demo fast, but the architecture supports it seamlessly. Virtual WAN is not just VNet connectivity. Enterprises use it to connect branch offices using site-to-site VPN. Remote users can connect using point-to-site VPN. Data center can connect through ExpressRoute. All these connections terminate in this virtual hub. Azure then provides transitive routing across the entire network fabric. That means a branch office, a cloud workload, and a remote user can communicate securely through one managed architecture. Why this matters, right? We need to understand why Azure uh, WAN is so powerful. The real power of a virtual WAN is that connectivity, routing, and security are centralized and scalable. Instead of building complex network topologies manually, we define intent and Azure implements it. This reduces operational overhead while supporting enterprise scale networking. Now, in today's demo, showed the core idea of virtual WAN using a simple lab. Two networks connected through a managed hub with automatic routing. In real-world deployment, the same architecture support firewall inspection, branch connectivity, remote access, and multi-region scaling. Understanding this foundation prepares you to design modern Azure network with confidence. So, thank you for watching my video, and I request you to give me feedback what all things I need to improve upon, and if you have any special topics on which you want me to create a video, do let me in the comments. Thank you for watching my video.